So for R&D lab, we did how the angle of curvature of lenses, like how much they curve, affects where the images they form are relative to the line of action of the lens.
So we had two hypotheses. One was that larger angles of curvature create smaller focuses for real and virtual images. And another one that we just wanted to prove to ourselves, diverging lenses create only virtual images, and converging lenses create real and virtual images. But we also kind of took a side quest and figured out where virtual images appeared and why for a lot of lenses, just because we found that some of them had two, and we wanted to see why this all formed. So here's some definitions just so you'll know, because we weren't quite sure exactly what a virtual image was before we started this. It's kind of where an image would appear if all the rays that are going forward came back at a point, and it's not actually there. If you put a piece of paper there, it doesn't exist, but you can still see it, so it's kind of weird. But real images are like you can see the light on a wall, and it's actually there.
And just diverging lenses are lenses that when the light goes through them, they spread light out, so they don't form real images. They're like lenses that are double concave. Sorry.
Yeah.
Yeah, these lenses, yeah. And they cause the light rays to spread out, while converging lenses do the opposite, and they focus light at a point, so they actually do form real images, as well as virtual images sometimes. So this is our experimental setup. We used the optics track thing that we used last year. So this is a light box, and it has a little image, and we used a 4. So this was a little lighted up 4. And so we turn it on, and we shone it through the lens and onto a screen or the wall on some of the lenses that had really long focal points.
So we did lots of kinds of lenses. We did convex lenses, and you can see the virtual images here. So there was a real image on the wall for these, but there were two little virtual images. There was one right side up 4 and one upside down 4, and so we measured the distance to those. And this is just the ray diagram for the real image, and it shows that the light converges, because that's a converging lens.
You guys actually drew those, right?
Mm-hmm.
That's really cool.
And this is my guess at why the virtual images are there. So for a convex mirror, it creates a virtual image. And the virtual image there appeared sort of where a virtual image would appear if that first part of the lens were a mirror. So it's like that convex part of the lens is working as a mirror, and there's a virtual image. And the next one is upside down, and that sort of works like a concave mirror would, where it would create an image, but it shows it too far away. So I don't know why we had an image like right here upside down, but it works well that the convex side would be like a convex mirror. So that's kind of how it worked. It made a virtual image there. So that was really cool and unexpected. There's also another virtual image, I didn't make this picture, that would be found in convex lenses, and it's if you were looking through it at the object, it magnifies something. So you all have seen that lenses like this magnify things, and it's just that the light would converge there, but it doesn't really converge there. It just, like, if they went backwards, it would hit there, and that's kind of what virtual images are. We also did concave lenses, and they are diverging lenses, so they don't create a real image. They just spread light out. So even if you had the lens in front of the 4, there would be nothing on the other side. They have also 2 virtual images. One of them is just this one here, is just where the light diverges when it goes backwards like other virtual images. And the other one works sort of the same way, like a convex mirror with this end of it, but it did not work like a concave mirror because there were no upside down virtual images. But it looked like light kind of reflected off this edge to create another virtual image here, and this one is just the expected virtual image. Yeah.
If that were a concave mirror, it would create a real image down there.
Yeah,
right?
and so I was looking at that because convex mirrors worked, but the concave ones didn't. So they like created it too far away. So I don't know why those ones were actually there. Like for the convex lens, it looked like it might work, but it didn't actually. So I don't know why there was that extra upside down virtual image. Yeah.
Cool.
We also did positive meniscus lenses, which means that it's thicker in the middle than on the edges, and that is sort of what a converging lens is. Converging lenses, simplified, are thicker in the middle than on the edges, and diverging lenses are thinner. So they're also negative meniscus lenses where it's just thinner here. But they create real images that are about in the same spot if you flip it either way, which was cool because the real image doesn't depend on like which way the lens was flipped, which was really interesting to us. But it also created virtual images, 2 of them. So that one also worked like a convex mirror, sort of. It created a bigger one and a smaller one, and like, so this would be a mirror and this would be a mirror, and it created 2 images, but then I don't know why it works the other way too. So I have no idea. But this one looks like it works because they're off a little bit and they hit about the same right point. Yeah, so they look kind of like they would work like that, but then they would be real images, and I don't know. They look kind of right, but not quite.
So the virtual images where the real images should be?
Yeah, almost. And I don't know why they're there, but yeah. So we found some interesting virtual images. And these are just negative meniscus lenses. They're thinner and they diverge light. They don't have real images, but we didn't have any lenses like that to test.
So we had one weird lens that had different, like most of the lenses we tested had the same amount of curvature on both sides, but this lens was flatter on one side, although it still curved out. So it worked essentially the same way as a converging lens because it is thinner on the outside than the inside.
Yeah, it worked like the positive meniscus too, that you flip it and it had the same real image location, because the image depends on where the center of the lens is, and that's the same either way. But then the virtual images moved because they depend, I think, on how much it's curved. So that flipped around. Yeah.
Okay, so we measured where the images formed, and then we used those images to calculate the focal point of the lens. And so this graph, these are actually 2 separate sorts. These are the diverging lenses. These are the double concave that go like this. And this line up here is the double concave that go like this. Sorry, double convex. And so it shows that the characterization of concavity that I have is how much the height changed from the edge to the center over its diameter. So that's how much the height changed overall. And so as the difference, as the height got higher, it got thicker. The focal point got closer and the focal point is decreasing. And that's the reason that this is a negative slope. These were calculated with the virtual image, which formed in front of the mirror lens. And so you write the focal point of those with a negative number, which is why this is a positive slope, because it's getting closer to the lens, which is less negative. And so this is for the positive meniscus lenses, and it shows the same trend as the double concave lenses.
So we confirmed that converging lenses create real images and diverging lenses create only virtual images, but they all create virtual images in different places, which was really interesting.
And we also discovered that the greater the angle of curvature, and so like the curvier the lenses, the closer the images form, which supports our other hypothesis.
And so we were using equations in this that were supposed to be used for really simple lenses, so that's sort of an error because the focuses were close, but they weren't perfect because the lenses were kind of thick and more complicated. But it was good to like prove the concept so we could see it.
Yeah. And we didn't take into account how the glass affected the focal points because the light would travel differently through glass, and the lenses were different thicknesses because we weren't able to find the lenses that we needed or create them how we wanted them to be. So.
Awesome. Thank you.
Virtual images, and converging lenses create real and virtual images, but we also kind of took a side quest and figured out where virtual images appeared and why for a lot of lenses, just because we found that some of them had two, and we wanted to see why this all formed. So here's some definitions just so you all know, because we weren't quite sure exactly what a virtual image was before we started this. It's kind of where an image would appear if all the rays that are going forward like came
Relative to the line of action of the lens.
So we had two hypotheses. One was that larger angles of curvature create smaller focuses for real and virtual images. And another one that we just wanted to prove to ourselves, diverging lenses create only back at a point. And it's not actually there. If you put a piece of paper there, it doesn't exist. But you can still see it. So it's kind of weird. But real images are like you can see the light on a wall. And it's actually there.
And just so for R&D lab we did how the angle of curvature of lenses, like how much they curve, affects where the images they form are.